Right, homework paper 13, foundation tier. Here are the solutions. Let's get stuck in. Okay, question 1. What is the value of the 4 in the number 56,427? This is the hundreds column, so we are looking at hundreds, C. Question 2. One number is a multiple of 6. Which number is it? C, 24. 4 times 6. Question 3. The diagram shows a patio made from paving stones. Each paving stone is 1 meter square. 1 by 1. What is the area of the patio? That's simply a counting squares task. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 meters square. Common answer, common mistake with this is getting area confused with perimeter, and people count around the rectangle. Not the case here. We're looking at area. Question 4. 14,668 people went to a pop concert. What is 14,668 rounded to the nearest 100? So looking at the nearest 100. So we're looking at the hundreds column and then looking at the digit to the right of it. The digit to the right of it is a 6, which is higher than 5 or higher. So that means this is going to round up to 14,700. Answer A for this one. Okay, moving on. Question 5. Here's a sequence of patterns made from dots. Pattern 1, pattern 2, pattern 3. Pattern 1, 2, 3, number of dots in each, 4, 7, 10. How many dots are there in pattern 4? So with this one here, we want to have a quick check, make sure the common difference is the same each time. It's going up in 3s. So in pattern 4, we're going to add another 3 onto that. So we're looking at C13. Question 6. What is the special name for this triangle? All the sides are of equal length and so are the angles as well. This is an equilateral triangle. Answer D. And question 7. Here are the first 5 terms of a sequence. 7, 11, 15, 19, 23. Again, finding the common difference each time, that's super useful. Don't assume the difference is the same all the time with sequences. Sometimes the differences can be changing. This one, we have got +4 each time for our term-to-term rule. What is the 9th term of the sequence? So we could very quickly just count on the next few terms to get to the 9th term. We've got n equals 1, 2, 3, 4, 5. If we're after the 95th or the 178th term, it's going to be a bit more of a trick. So finding the nth term rule is super useful here. Quick way of doing this. Once you've established the common difference, that it's +4 each time, we know this is a variant of the 4 times table, so it's going to be 4n. If we remove 4 from that, we can find something called the 0th term. So 4 before the 7 would be 3. Your teacher may or may not have taught you this in this way. This is a quick fire shortcut way, 4n plus 3. We then put in the n. In this case, it's the 9th term. N represents the term it is in the sequence. So 4 times 9 is 36, plus 3 is 39. So our answer for this one is E. All right, moving on, question 8. Here is a list of temperatures. 2, 7, -1, -6, -3. Jeremy is going to write the temperatures in order. At first, he writes the lowest temperature. Which temperature should he write next? Read this carefully. He writes the lowest temperature first. Which temperature should he write next? We're not being asked to write the lowest temperature. We're being asked to write the second lowest, as in which one should he write next. So probably the best thing to do is just to rewrite these in order. -6, minus 3, minus 1, 2, and then 7. So we're after negative 3. It's the one he writes next. Question 9. The coordinates of point P are, so this is reading coordinates, along the corridor and up the stairs. 3 across, 1 up, D. Question 10. What is the size of the angle marked X? Angles on a straight line, also known as a half turn, add up to 180 degrees. So we need to add these two numbers up and subtract them from 180. So 65 plus 75 is the same as 70 plus 70. That's 140. Take that away from 180. That's going to leave us with 40. So the answer, D. Okay, question 11. Here is a list of numbers 25, 31, 27, 39, 21. One of these numbers is a prime number. Which one is it? And in this particular example, it is 31. 31 has only two factors, 1 and itself. All the other numbers have more than two factors. Question 12. What is the number 0.753 written as a fraction? There are 3 decimal places here. The first one is tenths, the second one is hundredths, and the third decimal place is thousandth. That's the clue. So we're looking for 753 over 1,000. Question 13. Here is a rectangle. It's a 4 by 5. The area of the rectangle is 4 by 5. 4 times 5, which is 20 centimeters squared. Question 14. The nth term of a number sequence is given by the rule 3n plus 1. Which number is not in the sequence? So in this particular example, there's a kind of a shortcut way of doing this. If the numbers were bigger, you'd have to set this up as an equation and check all of them. When n is 1, we're going to do 3 times 1 plus 1, so that's going to be 4. So it can't be this one because that is in the sequence. When n is 2, 3 times 2 is 6 plus 1 is 7. So it can't be that one because that is in the sequence. When n is 3, 3 times 3 is 9 plus 1 is 10. So it's not that one because we're after which one is not in the sequence. When n is 4, 3 times 4 is 12. 12 plus 1 is 13. And finally, if we look at this one here, when n is 5, 3 times 5 is 15 plus 1 is 16. And when n is 6, 3 times 6 plus 1 is 19. 1 in the middle of that was 13. So which one is not in the sequence is 15. Setting that up as an equation, you could set it up like this very quickly. 3n plus 1 equals 15. To check that that's not true, we will then subtract 1 from each side, and what we will then see is that n is not an integer. When n is not an integer, we can then establish that that number is not in that sequence. Question 15. What is 1.2 meters in centimeters? Well, there are 100 centimeters in 1 meter. So there's going to be 120 centimeters in 1.2 meters. Question 16. Before I even read anything, I can see this is isosceles. 2 either side the same. That means that's going to be 40 as well. That's going to help us. What's the size of angle marked X? Easy peasy lemon squeezy. 180 degrees altogether. 40 plus 40 equals 80. Take that off 180. Leaves us with 100. E. What is the size of angle X? That's that one, isn't it? Lovely jubbly. Okay. Question 17. 36 times 132 equals 4,752. The value of 3.6 times 13.2 is what? So how is that similar to that? And how is that one similar to that? Well, both of these are 10 times smaller. If both of these are 10 times smaller, that must mean the solution is going to become 100 times smaller. That means this goes like this. Start with 4,752. 10 times smaller is going to be that. And 100 times smaller is going to move a second place value across. So we are looking at B. A quick estimate tells us we have got 4 times 13, which is 52. So which of these answers is closest to 52? 47. So a useful little estimate check here for such a reasoning question. Question 18. At 6 p.m. in Manchester, the temperature was 2 degrees. By midnight, the temperature had fallen by 5 degrees. 5. So it's gone down by 5. What was the temperature at midnight? So it's gone down by 5. So it's going to go down 2 there and 3 more there. We're looking at -3 for part A. Question 19. The coordinates of the midpoint of line ST are what? So how do we find that midpoint roughly in there somewhere? We find halfway between the X value and halfway between the Y value. So 1, 2, 6 and 8. So halfway between 1 and 6, 1 plus 6 is 7. Half of that is 3.5. And 2 plus 8 is 10. And half of 10 is 5. So 3.5 and 5, which is that one there. Lovely little trick here for finding halfway. Find halfway, you can do, add them up and divide by 2. There you go. 3.55. Question 20. What is the area of this trapezium? So you've got 4 measurements here, and you need to know the formula for area of a trapezium, which is a half of the height times by A plus B, whereby this is the height, that is A, and that's B. This value, we don't need that. It's what we call a red herring, a distraction of sorts. Now, why does this work? We're turning this into a rectangle. I'm not going to go into too much detail on this, but half of the height is going to be too high. So we're turning this kind of trapezium that's that tall into one that is flipped over, and that is kind of flipped over, and it makes a rectangle that is too tall, and it's 9 plus 6 along. Hopefully that picture helps you make sense of where the A plus B is. So we've got 2 times 9 plus 6. We've got 2 times 15. So our answer for this one is 30 centimeters squared. Question 21. Which is the largest fraction? This is a tricky one. We need, ideally, a common denominator here. I'm looking at 60. All these other denominators go into 60. So we'll times that by 4, becomes 44. Times that by 6, it's going to become 54. Times that by 12, it's going to become 48. And times that by 3, that's going to be 39. Which is the largest fraction? 9/10. 54 over 60, slightly bigger than 53 over 60. And there might be other ways of coming to that conclusion. Question 22. The diagram shows a rectangular floor, 3 by 4 meters. And we've got the length and the width there. Beth wants to cover the floor completely with tiles. Each tile is a square of sides 50 centimeters. So if that's 3, then each of those is a meter, and each of those is a half a meter, which is 50 centimeters. Each of those sections from there to there is a meter, and each of those are half meters, or 50 centimeters. Sometimes it's quite nice to kind of annotate your diagrams like this. It might make sense of things a little bit more. How many tiles does she need? Well, she's going to need 6 by 8 tiles, because each one of those tiles looks something like that. Okay, you're going to have 6 of them that way, 8 of them across, 6 by 8. So 6 times 8 is 48 tiles. Another way you could do this is 4 times 3, which is 12. And then what you would need to do is divide by 0.5, which gives you 24, and then divide by 0.5 again. Because you're finding out how many halves go into something and halves again. So there's a couple of ways you could arrive at that conclusion. 23. The best estimate for this calculation is which one of these? Nice little estimate calculation. We've got 300 times by 10 all over. I'd say that's close to a quarter. So we've got 3,000 all over a quarter. So how many quarters go into that? That's going to be about, how many quarters? It's going to be basically times that by 4. That's going to be about 12,000. That's not one of the answers here. That was my first instinct. In this particular example, though, so let's imagine it's 3,000 over 0.2. Don't forget 0.2 is a fifth. So what we'd be doing is dividing 3,000 by 0.2. Lovely little thing we can do here is we can make both the top and the bottom 10 times bigger, turning it into whole numbers. So 30,000 over 2, which is 15,000. That's also the closest to my estimate of 12,000 in terms of the magnitude or size of the answer. So A is the best estimate for that. Okay, 24. 390 students are going on a coach trip. Each coach can take a maximum of 48 students. What is the smallest number of coaches needed? So we're effectively doing 390 divided by 48. Now, in this particular example here, there's a couple of things you could do. And if you're not sure about dividing by 48, you could break up something like 48 into its factors, which might make things easier. For example, I know that 48 is 3 times 16, or 4 times 12, or lots of other factor pairs. So I'm going to go like that. So I can do 3's into 390, once, thrice. So 3's into 390. I'm then going to do this a second time. How many 16s go into that 130? I don't really like that. So what I'm going to do here is, instead of dividing by 16, I'm going to divide by 4 and then divide by 4 again. So 4's into 130. 4's into 1. Nope. 4's into 13 3 times with 1 left over. 4's into 10 will go twice with 2 left over. There we go. 32.2. And then I've got to do 4's into 32.2. 4's into 32, 8. 4's into 2, none. 4's into 20, 5 times. So we're going to need 8.05 buses. We're going to need 9 buses. If we double check this the other way, 9 times 48, we can do 10 times 48, which is 480. Take away 48, and that is going to give us 432. So that would allow us to take 432 students. If we were looking at 8 buses, each bus takes 48, then you could do 480, take 96. That's 10 lots. That's just another way of thinking about it. That's 10 lots of 48, take away 2 lots of 48. That take away 100 is going to be 380. Then add 4, 384. 384, that's not enough. We need 390 students. So that proves, that's us showing that 8 is not enough. Showing. We have just shown that 8 is not enough. 8 will only get us 384, whereas 9 gets us 432 students. So I'm showing that 8 is not enough. Question 25. Here are the first 5 terms of an arithmetic sequence. 5, 8, 11, 14, 17. Plus 3, plus 3, plus 3, plus 3. Which is the expression for the nth term of the sequence? Right, it's basically the 3 times table adapted, so it's something with a 3n in it. It's going to be that one or that one. I can automatically cross out all of those. Is this the 3 times table? No. Well, it's not the 3n then. So therefore it is 3n plus 2, because it's the 3 times table with 2 added each time.